Good morning to all. Myself, Bijon Joseph. I'm working here in Electrical Department, Parul Institute of Technology. So we are here organizing a webinar on basics of artificial intelligence, and here we have our expert, Mr. Jeremiah Jacob, for this section. He is working as a system engineer in Emerson Expert Engineering Center from past 8 years. I'm welcoming him on behalf of Parul University to share his immense and valuable knowledge and enlighten us with his knowledge. We welcome you, Jeremiah Jacob, sir.
Hello, thank you for the time. Am I audible? All fine.
Yes, you are audible.
And the slide is visible.
Yes,
Okay. First of all, greetings everyone. And I take this privilege humbly uh, to spend some time regarding presentation for artificial intelligence. I know you will be knowing more of the information, but I believe a small information from my side might enlighten some of the thoughts of the people, some of the thoughts of the engineers who are listening to me. So, before I begin, I consider this as um, a two-way communication, but I feel that this is only presenting the information. So, if you see the market, so we can see there are many technologies which is turning towards artificial intelligence. If you look at the mobile phone, the mobile that you are using, you will understand that the camera, which is having a inbuilt artificial intelligence sensor, what it does is it will uh, utilize uh, the intelligence of a human being, and it will uh, project it in a better way. So let's learn what is artificial intelligence. First of all, definition itself says that it is a study of human intelligence and which is replicated artificially. There is a great saying which says the art of creating machines that perform functions that require intelligence when performed by humans. More than a human being can perform, we wanted the machines to perform the way humans are performing. It involves cognitive modeling. We have to determine how humans think in a literal sense. We need to understand how the human being is going to think, how a human being is going to make an action. Same feature we need to establish on a machine. The inner working of a human mind requires experimental inspection and psychological testing. So there are a lot of testing, there are a lot of experiments that we need to perform before before we create that artificial intelligence machine. Definition also says it is a science as well as engineering of making intelligent machine, especially intelligent computer programs, some logics, and it's also a problem solver, and it also deals with the right thinking and divides into a field of logic. So that's what the definition says. It is a machine which is acting like a human being. Let's go to the next objective. The objective of this machine is Physically, they are not human. Physically, they are machines, but they should think like human beings. Physically, they might not think rationally, but we need to make the system to think rationally. Physically, the system might not act like a human being, but we need to make the system to act like a human being. We need to make the system action like a human being. And so, objective of this artificial intelligence system is that it should think like humans, focus on more on reasoning and human framework, how the human beings are thinking, and it should also focus on reasoning and a concept of intelligence. It should also focus on behavior like a human being, and it should also behave like in a human framework. It should also act like how a human being is going to act and how a human being is going to think. Next, I will move to the structure of AI. So, in the structure of AI, there are three parts. Okay, the first part that I will say is called as AI areas, or the way where AIs are going to work. And the second part is the methods, and the third part is the techniques. So, three things: one is the areas, second is the method, and then you have the techniques. In the areas, you will have the uh, deduction systems, expert systems, robotics, and sensors to vision, computer vision, and it also have natural language processing, which will help the human beings to communicate. It's like a human machine interface. Then you have something called as methods and techniques. In the methods and techniques, what it it has is, it has the knowledge representation, how the code is going to get represented, and it has its own languages, and it has its own system, and it has automated reasoning, which is used to store information with the history information, to answer questions and to draw some conclusions. And it has planning and problem resolving. Planning and problem resolving is like, you have some when it sees a problem, it will plan the codes accordingly, it will plan its logics accordingly, and it will execute. So this is the a structure of AI. And in a funny way, we can say is like, happens to be, we can say the brain, our brain, we are intelligent, we say we are the intelligent machine. So there is a funny saying which says the brain happens to be a meat machine. Brain is a machine, but it has some meat inside it. So one of the creative way which is represented the agents, it's like an ant. So you have the outside environment on your left, and you have the agent, that is the artificial agent, which is on the right. So there are some sensors. With the help of the sensor, it sees the environment, it sees the surrounding, it perceives the environment through the sensor, and then it will act upon the environment through the effectors. So that is what a artificial intelligence is. Like a human agent has eyes, ears, and other organs for sensor, and hands and legs and mouth and other parts of the body for effectors. We have seven sensors, right? Seven sense organs of our body. So five. sorry, five. So eyes, ears, and other organs act as a sensors. There are other parts which is our hand, mouth, legs, which act as a effectors over the environment. A robotic agent substitutes camera and infrared range finders for the sensors and various motors for the effectors. A software agent has encoded bit strings as it perceives and actions. So there are sensors which will sense it, and there are effectors which will take action upon the environment. Next is the structure of an agent. I believe there are many engineers who are listening to this video, and I strongly believe that you guys will be the future for this artificial intelligence, because now in this market there are a lot of opportunities for artificial intelligence. There are a lot of opportunities that people are looking for artificial intelligence. So I strongly believe there are many people who will be listening to it, will understand what exactly we are discussing. So next we talk about the structure of an agent. So as I told you before, like there is an environment and there is a percept and there is an action, and those are done by a agent. Now that agent is called as the artificial intelligence machine or an agent. So now I'm going to talk about that. So you have the sensors, actuators. It's an ant. On the head you have the general abilities, and on the body you have the applications which is related to the things that are going to observe from the sensors. So in the body you have something called as some motors, some robots, some soft boards, some mobile agents. So these kind of things are there in the body. So these are inbuilt as a body to the effect to be as an effector, and you have the sensors to visualize it. For example, you might have heard about the car called as Tesla car, which is automatically driven. So what it happens in the Tesla car is like the Tesla car sees through the sensors that is inbuilt on the car, and it uses the steering to take action over it. It uses the front wheel drive to change the gear, to change the steering, change the rotation, everything. It automatically creates it. So that is something like an artificial intelligent car, you can say like that. So the structure of an agent is you have sensors, you have some actuators. Very important, there should be a mouth, which is a communicating device. Generally, you might have seen in the cars that there is a touchscreen, right? There's a touchscreen panel. Generally, we say as entertainment device, but it is actually a human machine interface. In if you ask as an instrumentation engineer, we say that as a HMI or as a SCADA. We call it as a HMI or SCADA, human machine interface. So what it does is it's take the things from a human being and converts it into code, maybe a VB script, maybe JavaScript, maybe some PLC logic, some or other, maybe some 8085 communication processor codes, C code or C sharp code. It converts into some codes and it delivers from the effectors. That's what the agent does. Let's move ahead. Now, what is an I? It should do whatever action is expected to maximize its performance measure on the basis of evidence provided by the percept sequence and whatever built in knowledge the agent has. So it's like a clock. So clocks are kind of a degenerate agent in the percept sequence is empty. No matter whatever happens outside, the clock action is unaffected. Well, that is not quite true. If the clock and its owner take a trip from California to Australia, maybe to London, the right thing for the clock to do would be turn itself back and adjust the hours. Maybe 6 hours, 4 hours, 4.5 hours. We do not get upset at our clocks for failing to do it this because we realize they are acting rationally, given the lack of perceptual equipment. So why people uh, utilize the AI? Because they want to maximize their performance, they want to maximize their efficiency, they want to maximize uh, the product or production, and that's the reason they generally go for AI. Next is a simple reflex agent. Now let me give you an example. Let's look at a taxi driver. Okay, as I told you before, an example of a Tesla. Now, how Tesla was made? Let's look at an example of a taxi driver. Now, with the taxi driver, he has eyes. Now that has converted to as a camera. He has the uh, he knows the route. Now that has been converted to the Google Map or GPS, and he speaks, and that has been converted to microphone, and he has the hands by which he is turning the steer, which is now converted independently on the motors and on the brake wherever applicable, and he speaks to the customer comfortably. Yes, I talk about India. People talk comfortably to the passengers. No worries in that. So they talk to the passengers comfortably, and that is what is done from the HMI that is in front of you, or the infotainment system that is there in front of you, and he knows the route, which is the GPS, and that is been displayed on the HMI. So, if a car applies a brake, how does it applies a brake? Because it sees uh, uh, if you are driving, when do you apply a brake? Can anyone answer? Is that possible? When do you apply the brake? It's only when you see a car which is passing in front of you, which is showing a red light, or the front car, when it applies a brake, it shows a red light, and the same light, when we sees it, we apply the brake. That is what is happening, right? So if the car in the front brakes and it brakes, light comes on, and this taxi driver, it notices the light, and he initiates the braking. So so that's how this braking is happening to this taxi driver. So in other words, some processing is done on visual input to establish a condition we call the car in front is braking, and it triggers some action by the agent, and it initiate braking. So it's kind of a if and else statement. If you know how to write codings, VB script or any other coding, you will know there are some if and else statements. So if you see a car in the front braking, then establish initiate braking. If you don't see it, end if no 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 action. So these kind of conditions, rules are set on the agent to take action on the environment by taking the reading from the sensors. Now there are something called as state-based agents. So what is a state-based agent? It says if the car in front is a recent model and has a centrally mounted brake light, then it is possible to tell if the braking is from a single image. From the time to time, the driver looks in the rear view to check if there is any vehicle which is coming just behind him. So he is checking it. So this is a state based. So initial one was like, you saw the light and you apply the brake. Second one is you saw the light. Now the next action that you are going to do is there any impact, whether the rear vehicle will dash my vehicle. He will check and then he will do an action. So this is kind of a state base. Now how the state base is evolved is like there will be some history which will be collected, like for example so and so distance. If the rear vehicle is there, then apply the brake this much, 20%, 30%, 12%, these kind of. So this is part of a state based. Then you have something called as goal based agent. What is a goal based agent is, it is like, it is a principle where if the car in the front brakes, the lights on, and it slow down or it has stopped, from the way the world usually evolves, the only action that will achieve the goal of not hitting the cars is to brake. So the goal here is my agent should not dash the car which is there in front of you. So sometimes you might feel this is less efficient, but however this is more flexible agent. For example, if it starts to rain, the agent can update its knowledge. As I told you before, there was something called as uh, knowledge representation. This part, knowledge representation. So if there is a rain, it will on its agent, yes, there is a rain, and it will update its knowledge. Oh, there is water uh, on the glass shield. That means there are rains. There is waters on the rooftop. There is a sprinkling water. That means it's a rain. So it will update its knowledge, and effectively it will operate. What happen if you are traveling on a speed of 120 and you see a light in front of you and you suddenly apply brake which will reduce from 120 to maybe uh, 20, 10 and 0, you will be in a big trouble. Maybe then you will accuse the agent maker. So to avoid that, there is something called as goal based agent. What does the goal based agent does is it will check how effectively his brakes to operate, and automatically it will cause all the relevant behaviors to alter and make similar change in its new condition. So that's what a goal based agent does. Because the goal here is that there should be no accidents. He should travel from one place to another place safely. Then there is something called as utility based agent. What is a utility based agent? It's very interesting. It's it's described as the associated degree of happiness, customer satisfaction. Very important in the market. It gives feedback, then it solves the issues. Why I say is it's very important. Whatever, if at all you see anything in this market, if a person wants to establish his business to in a very, you will see there will be a customer feedback or customer survey which is maybe adjacent to it. Let's consider you visit to a hospital. And while leaving from the hospital, you will find a small desk where it says customer feedback. Good, fair, bad. Let's imagine you went to a restaurant. I have seen some of the restaurant. The harder you hit the bell, you are more happy. So it will check. The utility based agent will check. It will check the feedback from its performance. A complete specification of the utility follows rational decision in two kinds of cases where goals have trouble. First, where there are conflicting goals, only some of which can be achieved, for example, speed and safety. The utility function specifies the appropriate trade off. Secondly, where there are several goals that the agent can aim for, none of them will be achieved with certainty. Utility provides a way in which the likelihood of the success can be weighed against the importance of the goals. So it will always check the feedback from its performance, and it will add to his knowledge, it will add to his learning element, and then it will uh, issue it will generate a problem solving method, and it will solve the problem, or it will help the actuators to perform on the environment. I hope you're understanding what I'm trying to explain. Sorry. Next is a problem solving agent. Till now we were listening to a simplex reflex agent, simple reflex agent, state based agent, goal based agent, and utility based agent. Now we are going to listen about something called as problem solving agent. What is a problem solving agent? As a formulation of goal, the agent may wish to decide on some other factors that affect the desirability of different ways of achieving the goal. For example, suppose you want to travel to Dubai. So you will see there are, you will search on the Google, how can I travel to Dubai? You will get TripAdvisor giving one itinerary. You will say goibbro.com will give you another itinerary. Then you will give Travel Triangle giving another itinerary. Multiple, I make my trip giving another itinerary. Multiple trips you will get. But you, as a human being, what you will do is you will select, okay, which one is suitable for me. You will select that, and then you will you will achieve for it. So I have the trip to travel for 6 days, so accordingly I will select the tour. So that is a goal formulation. Next is a problem formulation. What is a process of deciding what action and state that I should consider, and what kind of goal I should formulate. For example, in a trip, whether I should go from whether I should go from London to Dubai, or whether I should go from Singapore to Dubai, it's up to me. Suppose I have a work which is there in the Oman for 2 days, and then I can go to Dubai, and then I can go to Kuwait for 3 days. So accordingly, that my agent will solve it. So that is kind of a problem solving agent. So accordingly, it will consider all your itineraries, and it will consider the complete trip. Next is a search solution. Very important. It is an algorithm. The Google, there are algorithms. For example, simple example, today if you type on the Google, travel to Dubai, next day, maybe in your Facebook, maybe in your Instagram, you will find some ads which are showing up, travel to Dubai. Dubai tickets are so and so rates. Dubai flights so and so available. So this is an algorithm, which connects your Google, your Facebook, your Yahoo, your Rediff, and everything. It will Instagram, everything. It will make as a sequence. So search solution is a it's takes a problem as an input and returns a solution in form an action as a sequence. Then you have execution. The next step of the problem solving agent is the execution. It uses the solution to guide its action, doing whatever the solution recommends. In the search solution, you will get the solution, and that solution it will execute, and it recommends what is the next thing that you need to be doing, and then removing the step from the sequence. For example, if you visit a doctor, after everything, he will tell you, okay, in the next visit, you should do this thing. It's just a recommendation. Next visit, you should do this, and come, it will be better for you. So this kind of a recommendation. So same way, the problem solving agent also recommends. Next is a knowledge based agent. What is a knowledge based agent that does is a set of representations. It has a set of knowledge. It will ask you, and you have to tell him. So ask and tell, or questionnaire. There will be a lot of questionnaire, and based on the questionnaire, it will create a sequence. It will create a facts. It will store its history, and based on it, it will execute. And based on the knowledge, there will be some language. Maybe the language is in some codes. Maybe the language in some language, C, Java, Python. Some language it will be there, and it will interface with the machine, and it will execute the program. So in the background, there are a lot of history that is being collected. There is a database that stores the history. It stores the data, and it executes. Next is a planning based agent. So planning based agent is a state. It opens up the representations of states and goals and action. And for example, uh, suppose you need to go and buy some milk or some shopping, or you want to go for sleeping. It will create, okay, if you go to buy milk, you have to install, you have to take so much, so and so money with you, maybe in Google Pay, or maybe in some UPI, or maybe some Phone Pay. And very important, in India you have to carry a bag, because nowadays shopkeeper doesn't give you a plastic bag, so you have to carry a bag, maybe a paper bag or a cloth bag. So these kinds of preparation, which will help as in the planning based agent. It also decides, before you go to buy milk, it also decides how you will be going there, what vehicle you need to take, and is there any necessary things that you need to order and plan and execute. So these kind of things, it will help. The planning based agent helps. The planner is free to add actions to the plan wherever they are needed. Most parts of the world are independent of most other parts. Why I say this is, there are many countries now uh, trying to be independent of their own resources. I don't want to dig in that topic much, but there are many countries trying to be independent of their own, trying to be build their own resources. So the agent also, the artificial intelligence agent also building its own history, building its own database. Why? So that it can become more independent. Next is a learning based agent. What is a learning based agent? Which is responsible of making improvements. Like I said you before, the customer satisfaction feedback will help to make an improvement of its own. It also has a performance element. What does the performance element do? It is responsible for selecting external actions. It guides the effectors. So this learning element takes some knowledge about the learning element and some feedback on how the agent is doing. It will take some feedback and help the actuator to modify itself so that it can do better in the future. Maybe the initial problem solving he might have taken 10 minutes. Maybe the next problem he will solve maybe in 3 minutes, 2 minutes, less than that. So it increases the efficiency of the performance, and that is what is required in the present market. Increase the efficiency. So very simple code that says maximum utilization and low cost. That's what happens in many of the businesses. Maximum utilization and the cost should be low. Then only you will get a good profit in your business. Then only you can grow in your business. Then only you can expand your horizon for the business. And the critic is designed to tell the learning element how well the agent is doing. The problem generator is responsible for suggesting actions that will lead to new and informative experiences. It would keep doing the action that are best given what it knows. But if the agent is willing to explore a little and do some, perhaps some optimal actions in the short run, it might discover much better action for the long run. So next is the agent that communicate. So there are many ways to communicate. When a baby is born, how does it communicate? It communicates with the sounds. It communicates with some gestures. It communicates with some physical signs. And there is no English, Hindi, or Gujarati language. But what is there? They generate its own language. If you look at a human being, and human being has its own language. Maybe the way I think is not the way Mr. Bijon thinks. It's not the way so Mr. Someone else is thinking. Everyone is thinking differently. Everyone is decoding their language. Everyone is storing their database. Everyone is storing their database in their own language. Most animals employ a fixed set of signs to represent some messages. Humans have also developed a complex, structured system of signs known as language. I can only say as one word as a language, and that enables them to communicate most of what they know about the world. Next, let's move for the application part. Now, till now, we were listening to what is artificial intelligence, and we were listening to uh, what are the uh, definition, the theory. But I believe you guys are from the MTech, and you guys are more interested to learn about from the application perspective. So if you look at the application, as I told you before, the simple mobile that you have also has a AI camera sensor. So you can understand how 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 vast, how helpful is artificial intelligence. Second is there are some places, for example, mining and all, where it's difficult for human beings to enter. It's difficult for human beings to go and work. Nowadays, people are using robots to reach there. What about on the moon? People are using now robots to reach there and explore. What about uh, one of the famous like for surgery? Recently, couple of years back, I visited a dental surgery, dentist, and he told me that suppose if you need to remove some of your teeth, he can only set on a machine, and that machine itself will remove, extract it, and place the crown and place the and set the teeth everything. You don't need to do anything, but the cost is very high. So if you look at the application part, artificial intelligence is very much required. Robots have nowadays replaced the human beings in the environment, where it is dangerous for humans, such as natural disasters, for the armed services. So having artificial intelligent robots in the manufacturing factories enables the efficiency of the production, and it becomes more precise. You might have seen lens cart, which is very common. So how does they make the frame? Initially, when we go to the chasmagar, what happens is the person will manually cut the glass and it make it the edges very smooth, and then he will fix it on the frame. And probably you will see some of the edges are little outside, some are inside. The vision maybe 5% here and there, but nowadays they are using robots. So what the robot does is it will measure the frames, it will measure the glass, and it will use the correct focal point. So the accuracy has become more important. The quality has become more. So now in the market, quality is very important. You need to have ISO certification, which is very important. How you get the ISO certification is you need to go to different stages of quality, then only you will get the ISO certification. And that's how. So if you go to the bigger customers, they look for how how good quality certificates you have. So how precise, how accurate your work is. So these kind of things are captured in it. Then you have another very famous video gaming. So in the video gaming, what you have seen is uh, you have your VDR where you see it, and you will do the action, and it works well. What about the diagnostic agent? Recently, like I should say today morning, my dad was hospitalized, and he was undergoing a surgery. So they are going to use something called as a laparoscopy, where they are going to inject the cameras inside the. They are not going to tear the body, but they're going to inject the cameras through some holes, and they are going to use the scissors and everything internally, and externally you will see very rare spots, or maybe three holes or two holes or something like that. So these kind of features have come up on in the market. So, and one more thing I just missed to say is, especially for the PCB boards, now you get your mobile phone compact, slim. Your Apple phones are very slim. Why? Because the chip inside it has become very small and small and small. Initially, when we were working for electronics, we used to have that the PCB board, where we have to inject the pins, the eight pins, or ICs. We have to connect the wires. We have to solder it. But now these things have reduced. Why? Because we are using more advanced advanced thing, that is the intelligence systems. So I hope maybe this session is was very helpful for you, and I want to humbly thank you, the Parallel University and Bijon, Mr. Bijon, for inviting me for this opportunity. I humbly take this opportunity, and I'm privileged to be part of it. And I would like to thank you. Thank you for those people who are behind the scenes, and thank you. And may this session be useful for you. May this session help you to think more rationally, think more differently, think more uniquely, in your coming future. Thank you.
Thank you, Mr. Jeremiah Jacob, for your valuable time you gave to us on your busy schedule, and thank you for your knowledge you shared with us, your experiences that you shared with us. I hope everyone uh, who are listening to this webinar, who are attending this webinar, got a basic knowledge or idea about the internet, artificial intelligence, and its example related to a daily life. Thank you, Jeremiah Jacob, once again for your valuable time. Thank you. Thank you.
I can leave now, right?
Yes, you can do.
Thank you.